All right, try to solve one question. Okay, Devra.
Yes, sir.
The question says, find the direction cosines of the line passing through the 2 points -2, 4, -5 and 1, 2, 3. Okay. Hi, Lisa.
Hello,
Please
sir.
solve. Hello, please solve this question on your screen.
Yes,
Okay.
sir. Yes, sir.
Let me check the answer. I do not have the answer for this, but let me calculate. Okay. Aliza, did you solve this?
No, sir.
Okay, you know how to solve this?
No, sir.
See, we have 2 points A and B, right? And the coordinates is -2, 4, and -5. 1, 2, and 3. They are saying the line is passing through AB. So we can figure out the line AB, right, which is OB vector minus OA vector. So 1 minus -2 is 3i cap, 2 minus 4 is -2 j cap, 3 minus plus 8 k cap. Okay. So if we have this, the direction ratios is 3, -2, 8. Right, whatever is the coefficient of I, j, k is the direction ratios. Okay, so direction cosines will be L will be equal to 3 upon this I cap coefficient upon the sum of this 3 square plus 2 square plus 8 square. Okay, which is 3 upon 9 plus 4, 1379. Okay,
Yes, sir.
M will be -2 upon root 79 and N will be 8 upon root 79. Okay, did I add it wrong? 9 plus 4, 64, 78.
Sir, isn't
I
that
think
supposed to be -2?
-2 square is also 4, right? So you can make it -2. No issues. So 4 plus 9, 13 and 64, 677. My bad again. 77. Okay. Both of you, this is clear?
Yes, sir.
Yes, sir.
Okay. So next topic, equation of a line in space. See, whenever you want a equation of a line, you need its direction and you need a point it's passing through, right? Or if you have two things, then we can always write the equation of a line. So same, the definition will carry forward and see how we get the derivation. Type 1 is equation of a line passing through a point and parallel to a vector. Okay, equation of line passing through a point, that means a point is given to you and it is parallel to a different vector. Okay, a vector form. We'll always study two forms in 3D, vector form and Cartesian form. So in vector form, suppose this is the line which is parallel a vector. Okay, and this is the coordinate. We have origin here, and suppose this is the OA. Okay, let's name this B, actually parallel, and this is a vector supposedly, and all the points that we need, this is suppose R vector. Okay, R is, remember this, R is the random point. Okay, whenever we are trying to write the equation of a line, we need the different coordinates, right? That is how we'll get a line. So R is the point of any point x comma y comma z on this line. Okay, this thing is clear.
Yes, sir.
So very
Yes, sir.
simple. If this line is passing through R and A, so I can say AR vector is parallel or collinear to B vector, and if this is true, then we can write AR vector equals to lambda times B vector. Yes or no? if two vectors are parallel, that means they are collinear, and if two vectors are collinear, we can say one vector is some constant multiplied by the second vector.
Yes, sir.
So AR vector is R vector minus A vector, which is equals to lambda times B vector. We can say R vector equals to A vector plus lambda times B vector, while lambda is a variable. Okay, you will be given A vector and B vector. A vector is a point line is passing through. The point line is passing through, and B is line parallel to this line. Okay, note it down. Okay, so this was the vector form in Cartesian form. Cartesian form means x y z. ठीक है, बचपन से जैसे हम कर रहे हैं. So suppose A vector, the line is passed through A vector, which is x1 I cap plus y1 j cap plus z1 k cap. ठीक है, ये A vector की position vector है. Line is passing through A vector, and B vector is suppose ai cap plus bj cap plus c k cap, क्योंकि ABC is the direction ratio, अगर आपको याद हो. ठीक है, and r vector is the general vector, so xi cap plus yj cap plus z k cap. ठीक है, so A vector, this is and this is r vector. We have to find this thing. Okay, the equation we got is r vector minus a vector should be equal to lambda times b vector. So let's just put the values here. R vector is xi cap minus yj cap, sorry, xy cap plus yj cap plus zk cap minus a vector is x1i cap plus y1j cap plus z1k cap, and this should be equal to lambda times b vector is ai cap plus bj cap plus c k cap. If we simplify this, we'll get x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap is equal to lambda times ai cap plus bj cap plus c k cap. Now if we compare these two, so we can say x minus x1 must be equals to a lambda, y minus y1 must be equals to b lambda, c minus c1, sorry, x minus z minus z1 should be equals to c lambda. Okay, so from here we can figure out lambda is x minus x1 upon a. Here also lambda is y minus y1 upon b, and here lambda is z minus z1 upon c. So if both are equal, all three are equal to lambda, we can say x minus x1 upon a is equals to y minus y1 upon b is equals to z minus z1 upon c. This is the equation of line in 3D. It looks very different, but we have to deal with it. Just remember here, whatever is in denominator a, b and c, this is the direction ratio. ये आपको याद रखना है, life will be very easy. ठीक है, and x1 y1 z1 is the point passing through. अगर ये दोनों बातें याद हैं, then you can write any equation of line. Okay, x1 y1 z1 is the point on the line, a b c is the direction ratio, and remember x y z के coefficients हैं 1. Always keep them like this. The coefficient of x y z should be 1. Is it understood what I said?
Sir, should be
Yes.
what?
Coefficient should be 1.
Okay, okay.
Okay, so take common, divide whatever you want, but always make it 1. Okay, clear?
Yes, sir.
Okay, note it down. Done, everyone? Yes or no?
Yes, sir.
Okay, a few questions on this. Find the vector and the Cartesian form, a Cartesian equation of the line through the point 5, 2, -4, and which is parallel to the vector 3i cap plus 2j cap minus 8j cap. Okay. Okay, Devora, good answer. So here A vector is 5 I cap plus 2 j cap minus 4 k cap, and B vector is 3 I cap plus 2 j cap minus 8 k cap, right? So R vector will be equal to, in vector form, A vector plus lambda times B vector, which is 5 I cap plus 2 j cap minus 4 k cap plus lambda times 3 I cap plus 2 j cap minus 8 k cap. In Cartesian form, we have to have x minus x1, which is 5 by this parallel vector 3 is equals to y minus 2 by 2 is equals to z plus 4 by minus 8. Okay, Aliza?
Yes, sir.
Okay. Next topic, type 2. Equation of line passing through two given points. Okay, if you have two vectors, two position vectors of 2 points, then how do we figure out the equation of line passing through them? It's also very easy. You need to figure out the equation of AB. Suppose we say this is A vector, this is B vector. A vector is the position vector of A, B vector is the position vector of B, and R is the general vector, position vector of points. Okay, let's extend this right here. This is R vector. Okay, here AB vector, can we find AB vector? Yes or no? Can we find AB vector?
Yes, sir.
It will be B vector minus A vector, right?
Yes, sir.
And AR vector is R vector minus A vector. And now we can say both are collinear, right? Because they are the same vectors. So we can say they are collinear. So R vector minus A vector is equals to lambda times B vector minus A vector. Okay. We can say R vector is equals to A vector plus lambda times B vector minus A vector. Okay. This is the equation of line passing through points. Okay.
Yes, sir.
Yes, sir.
Note it down. Done?
Yes, sir.
Okay, in Cartesian form, A vector, let's name it x1 I cap plus y1 j cap plus z1 k cap, and B vector is x2 I cap plus y2 j cap plus z2 k cap, and R vector is, as we all know, xi cap plus yj cap plus z k cap. We got the equation as R vector equals to A vector plus lambda times B minus A vector. So we can say R vector is xi cap plus bj cap plus zk cap is equals to A vector is x1 I cap plus y1 j cap plus z1 k cap plus lambda times b minus a. So we can say this is x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Okay. Again, let's bring this a vector to this side. So we'll have x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap is equals to lambda times x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Again, if we compare the same things, then the final result will be x minus x1 upon x2 minus x1. If you see one comparison, x minus x1 should be equals to lambda times x2 minus x1. So lambda will be equals to x minus x1 upon x2 minus x1. And this is equals to y minus y1 upon y2 minus y1 is equals to z minus z1 upon z2 minus z1. Okay.
Yes, sir.
Yes, sir.
Here both the points are on the line. So if you ever get 2 points, then this is the formula to use. Note it down. Done?
Yes, sir.
A few questions. Let's find the equation of the line passing through -1, 0, 2 and 3, 4, 6. Okay, you have to find both Cartesian and vector form and tell me the direction ratio of the line also. Okay. Okay.
Okay, sir.
What the answer?
Sir, is the answer minus I cap plus 2k cap plus lambda 4i plus 4j plus 4k?
Yes, absolutely correct. Okay. So in vector form, r vector equals to a vector plus lambda times b minus a. Anyone can be a, anyone can be b. So let's take this as a vector. So minus I cap plus 0 j cap is 0, 2k cap plus lambda times b minus a. So 3 minus 1 is 4, 4 minus 0 is 4, 6 minus 2 is 4. Okay. Now if you have to convert this in Cartesian form, see, once you get vector form, then Cartesian form is absolutely easy to convert, right? Because this is the passing point and this is the parallel. So we can say x minus or x plus 1 by 4, right? This is a vector, this is the b vector, first form, if you remember. And this is y minus 0 upon 4 is equal to z minus 2 upon 4. This step is clear? How we got this?
Yes, sir.
Okay. One more question. The Cartesian equation of a line is x plus 3 by 2 is equals to y minus 5 by 4 is equals to z plus 6 by 2. Find the vector equation for the line. Okay. Got the answer?
Yes, sir.
Okay, what is the answer?
Sir, minus 3 I cap plus 5 J cap minus 6 K cap plus lambda multiplied by 2 I cap plus 4 J cap plus 2 K cap.
Right, and that is equals to R vector, right? Don't
Yes, sir.
forget to write that.
Yes, sir.
Very good. One more question. The Cartesian equation of a line R 6x minus 2y equals to 3y plus 1 equals to 2z minus 2. Find its direction ratios and the vector equation. Okay.
Sir, that's 6x minus 2y.
Yes. So how to solve this? You can figure out everything in one variable, right? You can take this two equations and find x equals to something or y equals to something. Then you can do the same thing with these two, right? You can get some y equals to something, some form of x here, and from these two also you can get y equals to some form of z. So if x, this quantity, suppose this is p is equals to y and this q is equals to y, then we can say p is equals to y is equals to q. Okay, so then you will get the standard equation. Got it what I said?
Yes, sir.
Yes, sir.
Okay, let's see. From these two, we can say 6x minus 1 is equals to 5y, or 6x minus 1 upon 5 equals to y. Okay. And from these two equations, we can say 3y plus 1 equals to 2z minus 2, which is 3y equals to 2z minus 3, and y equals to 2z minus 3 by 3. So we can say 6x minus 1 upon 5 equals to y equals to 2z minus 3 by 3. Even now this is not in standard form because the coefficient should be 1. So we can take 6 common. We can write x minus 1 upon 6 by 5 by 6 is equals to y minus 0 upon 1 is equals to, if I take 2 common, this is z minus 3 by 2 upon 3 by 2. Okay.
Yes, sir.
So now we can get the vector equation and the what they were asking, direction ratios. So these are the direction ratios, right? One more question. Find the point on the line x plus 2 by 3 equals to y plus 1 by 2 is equals to z minus 3 by 2 at a distance of 3 root 2 from the point 1 comma 2 comma 3. Okay. Now how do we solve this? Whenever they talk about a point and a line, we always assume a point on the line. Okay. Whenever they talk about distance between points and anything like this, we assume a point. And how do we assume a point on a line? We have this equation of line. We can say this is equals to lambda. So if I compare the first one with the last one, I can say x is equals to 3 lambda minus 2. If I compare second one and the lambda, we can say y equals to 2 lambda minus 1 and z equals to 2 lambda plus 3, right? So you've got this point, right, Deborah?
Yes, sir.
Now all you have to do is find the distance between this point and compare that with 3 root 2. Okay,
Yes, sir.
find the answer. Okay, Deborah, got the answer?
Doing, sir.
Okay. This is 3 lambda minus 2 minus 1 square plus 2 lambda minus 1 minus 2 whole square plus this is 2 lambda plus 3 minus 3 whole square should be equals to 3 root 2 square, which is 18. Okay. So if we open this, we'll have a 9 lambda square here. Okay. And from here, we'll have a 4 lambda square. And from here, we'll have a 4 lambda square. And plus here, this is minus 3 square is 9. Minus 3 square is 9. And this is 0 square, so nothing. And here we'll have a minus 2ab, which is minus 2 times 3, 6 times 3, 18. And here 2 times 2, 4 times 3 is 12. Okay, is equals to 18. So we can see this 9 and 9, 18, it is cancelled. So all we have is 8, 16, 17 lambda square minus this is 30 lambda is equals to 0. We can take lambda common, 17 lambda minus 30 is equals to 0. So lambda can be 0 or lambda can be 30 upon
30 by
17.
17.
Okay, got it?
Yes, sir.
All right. So everything is clear about today, Deborah?
Yes, sir.
All right, then this is all for today's class. Okay. Take care.
Sir, you said
Yes.
you'll take an extra class tomorrow and day after tomorrow, right?
Yes, but no student is there today. Actually, they have been like doing the exams, so I don't know if they will join or not. We can keep if you want, but I'm not sure if other students will join or not.